Fiber Reinforced Polymer (FRP) matting is a foreign object debris FOD cover for repairs over any backfill material, including soil, flowable fill, deteriorated pavement, and crushed stone backfilled craters. FRP was transformative in its role of temporary repair of airfield operating surfaces and is the alternate solution for the previously used folded fiberglass mat (FFM), which, at the time, was not strong enough to withstand traffic from C-17 aircraft. FRP matting was designed to provide a modular FOD cover for airfield damage repair (ADR) over crushed stone crater repairs on runways, taxiways, and parking aprons. The material offers a durable, flexible, and tolerable repair option that can be deployed quickly. In this lesson, you will learn FRP uses and performance, FRP components, proper FRP installation, FRP inspection. Let's get started. Fiber Reinforced Polymer matting is composed of composite materials and blends high-strength fibers with a polymer matrix. This dynamic combination results in a material that goes beyond traditional solutions, offering strength and flexibility for the repair. FRP is installable on both asphalt and concrete surfaces. It is designed to support mixed traffic loads. It has been live flight tested with the A400M, C-17, F-15, and F-35 aircraft. It is not US DoD approved for the C-5, VTOL, or UAV aircraft. FRP is notionally rated for 100 passes of mixed traffic. The stronger the base material, the more sport passes it can withstand. If installed with an aggregate backfill, it can withstand 100 passes. If installed with stabilized backfill, it can withstand 100 to 500 passes. If installed with flowable fill, it can withstand 500 passes. FRP is designed to endure most fighter and cargo aircraft, but it does have its limitations. Its main failure point will be crushed stone crater repair. FRP also does not support vertical and/or short takeoff and landing, VTOL and STOL. FRP is also not compatible with tailhook operations and should not be placed within 500 feet of the lead-in to an arresting system cable, 50 feet after a cable for unidirectional applications, or 550 feet on either side of an arresting cable used with bidirectional applications. Regular inspections of the FRP UTC are vital to identify wear or damage and to ensure the UTC remains fully mission capable. The panels can be damaged by ultraviolet light. This requires that they are covered by a tarp for sustained outside storage. Within the fielded quadcons, there are small engines that need to be exercised regularly and drained after use. The tools and equipment within the UTC should be kept out of the elements, but inspected periodically, watching for rust or any other damage. It is important to promptly address issues and adhere to recommended repair procedures. Systematic maintenance plan preserves FRP matting, contributing to safe and efficient airfield operations. Always refer to the manufacturer's guidelines for specific care instructions. Executing the assembly and installation of FRP matting demands a coordinated effort involving a minimum of 8 personnel. This team includes a crew lead responsible for overseeing tasks, personnel, safety, and complying with correct procedures, and assisting with the placement and construction of the matting. 2 airmen are designated for adjusting individual panels and installing upper joining bushings. Without the aid of a CTL or forklift, a full mat panel is a 6-person lift. In select use cases, such as when conducting expeditionary airfield damage recovery, or EADR, teams may be required to construct a mat expanse with less than 8 airmen. Mat panels may be moved with a CTL or forklift, decreasing the number of airmen required to lift and place the matting. Essential equipment for the FRP mat installation comprises the FRP mat set, anchors, grout, and a toolkit. The necessary vehicles include a 10K forklift or CTL, a vehicle with a 2-inch receiver, and a tractor trailer optionally equipped with an additional trailer for efficient deployment of the FRP matting system. Now let's look at the components of FRP matting. An FRP mat consists of panels and anchor panels. A full panel weighs 400 pounds and its dimensions are 208 inches by 78 inches, or 528 centimeters by 198 centimeters. A half panel weighs 200 pounds and its dimensions are 108 inches by 78 inches, or 274 centimeters by 198 centimeters. A set also comes with full and half anchor panels. A full anchor panel is 208 inches by 24 inches, or 528 centimeters by 60 centimeters, and weighs 130 pounds. A half anchor panel is 108 inches by 24 inches, or 274 centimeters by 60 centimeters, and weighs 65 pounds. An FRP anchor kit has 600 upper connector bushings, 500 anchor bushings, 480 concrete expansion anchors, and 480 tri-talon anchors. Now let's look at panel construction for FRP. The panel is designed with overlaps and underlaps. The underlap has lower bushings permanently installed. The USAF assigns the kit as the 4FWFR FRP FOD cover kit unit type code, or UTC. The kit includes FRP matting, specialized components, and tools to assemble and install FOD covers for 20 10-foot, 6 20-foot, and 3 30-foot craters, or 1 50-foot crater. Package also consists of grout and anchor kits. Let's take a deeper look at the 4FWFR components. The bundle includes 4 mat sets, 7 full panels each, 6 half panels each, 3 full anchor panels each, 4 half anchor panels each, 1 tow kit optional, 1 roll of geotextile fabric, 1 anchor kit, 500 anchor bushings, 600 upper connector bushings, 480 tri-talon anchors, 480 expansion anchors, 1 grout kit that consists of 140 rapid set concrete buckets, and 1 tool kit that includes hydraulic and electrical tools, a generator, compactors, hand tools, and more. It is vital that the mat expanse must be installed perpendicular to the operation direction, or center line of the runway. The mat must be within 5 degrees of rotation to perpendicular. It cannot be used 500 feet 152 meters prior to, or 50 feet 15 meters after an aircraft arresting system. It is critical that no longitudinal joints are in alignment from row to row, meaning it must be installed in a brickwork pattern. This includes all panels and anchor panels. It is crucial to adhere to standard personal protective equipment guidelines, including wearing safety-toed footwear, gloves, and hearing protection consistently. Safety glasses are needed when drilling anchor holes and mixing mortar. N95 respirators are required when drilling concrete pavements and mixing mortar. Fiberglass slivers can be produced during the process, posing a risk, and the tri-talon anchors also have metal slivers that could harm exposed body parts. Emphasizing best practices, a full mat should ideally be lifted by a team of 6 individuals, while a half mat requires a 4-person lift. Lastly, when handling anchor panels, it is recommended to have a 2-person lift, ensuring the safety and well-being of the installation team throughout the process. Let's go over the assembly considerations when it comes to installing matting. Prior to mat assembly, the team lead must confirm they have enough matting to conduct all of the required repairs. Additionally, it is recommended that the matting layout be determined for all required repairs before construction of the matting takes place. It is preferred the mat be assembled on the repair. It is also important to be careful not to disturb the base material during construction. Another method is assembling the mat adjacent to the repair. With this method, you are allowed to drag the mat up to a 0.5 mile or 1.6 kilometers over the repair site. After dragging the mat, you must check 20% of the bushings prior to installation. The drag area should be fawed clear, and you must also be careful not to disturb base material. Matting must be constructed with 12 inches of minimum coverage over sound pavement on all sides of the crater. Additionally, anchors cannot be within 6 inches of any expansion joint or cracks in the pavement to prevent further damage to the parent slab. Finally, all mat expanses must be rectangles when completed. Now let's go over the actual assembly process. The first panel is placed on the right side of the trailing edge. The second panel is placed to the left of panel 1. Ensure you are properly aligning the upper and lower connector bushings during installation. Next, you hand tighten the upper bushings. Align the first 2 panels if assembling on a repair. The third panel is placed on the second row. At this point, ensure to at least set the bushing shoulder fully into the hole. Remember, it's critical that no longitudinal joints are in alignment from row to row, meaning it must be installed in a brickwork pattern. This includes all panels and anchor panels. Again, only hand tighten the bushings. When installing the mat, your team will have to make micro adjustments using a shovel, wonder bar, sledging, blocking, or kicking. Only one person should provide these instructions. Continue building rows 1 and 2 until proper width is established. Install the longitudinal bushings first, then traverse. If aligned properly, all of the joints will be approximately 0.5 inches or 1.25 centimeters wide, but not to exceed 0.75 inches or 1.9 centimeters. Place panels 6, 7, and with the same procedures mentioned earlier. Once the third row is in place, final torquing can begin. Initial torquing is accomplished with the impact wrench and torque limiter. Once the socket stops turning, count to 8. Final torquing must be accomplished with the torque wrench set at 110 foot-pounds or 150 newton meters or Nm. Using extension is not allowed. Pull the wrench slowly and steady until it clicks. Reset the wrench to 0 foot-pounds or 0 newton meters when finished. Now let's go over towing. First, you install 2 straps to the anchor holes. Should be on the outside thirds of the mat expanse. The straps need to be equidistant so the mat pulls straight. Utilize chains to attach tow straps to the vehicle, preferably a forklift. If using a forklift, orient forks 1/3 under the mat and connects chains to the carriage. If using a vehicle, attach a hitch or tow hooks. Next, we will align the mat on the repair. Place a traffic cone in the center of the mat expanse and place 2 traffic cones to the right and left of the repair center line. Using the forklift, slightly lift the mat. Have spotters with square head shovels on the leading expanse corners. Slowly pull the mat to the repair. Align the cones while ensuring 12 inches or 30 centimeters of overlap with the existing pavement, and anchor holes are not within 6 inches or 15 centimeters of cracks. Finally, ensure the mat is within 5 degrees of rotational tolerance. Let's discuss the anchors needed to install the mat. First, we have the steel wedge expansion anchors. It is a basic sleeve anchor used in any concrete at least 9 inches thick. Next, we have the tri-talon anchor. It is used in thin concrete less than 9 inches or 23 centimeters, and asphalt thicker than 4 inches or 10 centimeters. It utilizes grout to secure the anchor. The anchor bushing is stated to be drilled into the pavement at least 10 inches deep. Recommended marking the drill bit at the 10-inch mark with a piece of tape or spray paint, so the driller knows when proper depth has been reached. When the drilling is occurring, an air gun is used to blow away the debris. It is recommended all members use N95 mask or equivalent during this process. When anchoring the mat, only the leading and trailing edges of the mat are anchored. Ensure the crown is between two anchors and all mat gaps are less than 3/4 inch or 2 centimeters. Work from either right or left side of the mat, not skipping any anchors. Now let's walk through the steel wedge expansion anchor installation. Use the anchor bushing as an alignment aid and drill 3/4 inch or 2 centimeter hole at least 10 inches or 25 centimeters deep. Use spotters to ensure drill remains plumb. Blow drillings from the hole and surrounding area. Pay attention that no material builds up under the mat. Set the bolt through bushing. For the initial torque, use an impact wrench with torque limiter. For the final torque, use a torque wrench at 110 foot-pounds or 150 Newton meters. Next, we have the installation of the tri-talon anchor. It is recommended to practice the installation of the tri-talon anchor on the shoulders prior to attack to fully comprehend the procedures. First is to use the electric hammer drill or hydraulic drill to drill the 2-inch hole through the pavement. Then use the electric hammer drill with the SDS max extension or the hydraulic earth auger to drill the 2-inch hole into the base course. We will now look at the same procedure using the hydraulic drill. We will now look at the utilization of the hydraulic earth auger and how to drill the 2-inch hole. In a separate video, we will demonstrate the auger and anchoring procedures for an in-depth instructions on this vital piece of equipment in the FRP installation process. Use set tool to compact loose material. Disassemble tri-talon anchor and remove rubber band. Set the anchor in the hole. Then use the set tool to deploy talons. This may take several blows in high-strength materials. Pulling the anchor is not always indicative that the talons have been deployed. Reattach coupler and screw down until it's flush with the existing pavement. This is when the talons will either set or walk up. You should hear the impact wrench bog down. If the wrench does not bog down, then the talons are walking up the rod. It is critical to not let the talons come up too far. Reinsert the bolt into the coupler. After making sure the anchor is centered in the hole, and after there is at least 3 holes prepared, mix and pour grout into the hole using the provided funnel. It is recommended to cut off the end of the funnel, giving more space for the grout to flow through. Follow manufacturer guidance for mixture. It is allowable to add more than the recommended volume of water to the mix when preparing the grout. This will ensure the grout does not flash set before it's placed in the holes, especially when preparing grout in high temperatures. Utilize dowels to coax grout into the holes and fill flush to existing pavement, then remove the bolt. Set the anchor bushings and insert the bolt and only hand tighten. Once grout sets, after a minimum of 2 hours, anchor the bolt. Let's discuss some issues that you might run into when installing the anchors. If the mat is damaged or if an anchor fails to achieve torque, remove it and the anchor bushing. Utilize the hole saw to drill a new anchor hole in the mat and set another anchor, maintaining at least 6 inches between anchors. If a corner fails final torquing, remove the anchor and anchor bushing. Drill a new anchor hole on the transverse edge of the mat, as well as one anchor hole in line with the other anchors, to ensure the corner of the matting does not move when aircraft are trafficking. Holes should not be closer than 3 inches edge to edge. If the matting is damaged and will not lay flat along an edge, use the provided saw to cut off the areas of concern. After installing the matting, conducting essential final checks is imperative. Final checks involve accounting for all tools and ensuring a FOD-free environment. Paying specific attention to the mat joints is crucial, with a need for potential chipping of the grout. These meticulous checks ensure the overall integrity and effectiveness of the installed matting system. Now the installation of the matting is complete, it's time to inspect your work. After 10 aircraft passes, check mat rotation to see if anything appears to have shifted. Check the torque on 10% of bushings and anchors. If any failures, check 100% of the bushings. 10% of the check should be different bushings and anchors each time. Check the mat for missing non-skid material. Also, check mat expanse for cracks or failures. Finally, check the mat edges for pop-ups. Then allow 20 passes. Perform all 10 pass checks. Check for sag and base course rutting and utilize a dump truck to depress the mat. Utilize our QC stanchions to measure the rut for failures. If failures exist, unbolt the mat expanse and drag off. Rework the base course and drag the mat back over the repair and re-anchor. Fiber reinforced polymer FRP matting proves to be a vital component in ADR operations, playing a crucial role in swiftly restoring aircraft launch and recovery surfaces. Improper installation of FRP matting can pose potential risk, endangering both pilots and their aircraft. Therefore, strict adherence to the outlined procedures during the installation process becomes paramount for ensuring the effectiveness and safety of airfield operations. Airfield damage repair opens, sustains, and recovers airfield operating surfaces. Following the procedures outlined in this training will help ensure a level aircraft operating surface, allowing for mission continuation. Congratulations, you have completed this lesson. In this lesson, you have learned about FRP uses and performance, FRP components, proper FRP installation, and FRP inspection. For additional information, visit the AFTEC Expeditionary Engineers SharePoint.